Some time ago, I helped a friend of mine to complete his test task to the full stack tech lead position. So he was applying to a job position, and I was his reviewer of the task he is doing for that deployment. So the essence of a task was to create a prototype of a user management system with ability to create new user, login users, and also to work with a list of products. So once again, this is a task for the full stack tech lead position. So my friend decided to use the best technologies he knows. This is first of all React.js with a correct React app. For a backend, he decided to use API with Node.js and Express.js. And for the database, he decided to use MongoDB. Pretty nice set of technologies. Once again, he knows this the best, and that's why he has created the test task using the best what he knows. Unfortunately, he has failed, and the reason for the failure was the backend does not use real production technologies. So it seems that the backend part of his test assignment was far from the company expected, and probably this was the problem. So he has created with Node and Express, and it seems it was like his mistake. Also from his feedback, I know that he was struggling with API deployment and specifically with SSL configuration. Yeah. Also, during the troubleshooting of the deployed API, he struggled with lack of logging, with lack of observability of the problems inside the API and whole backend part. Okay, so what we can do with that? In this demo, I decided to create the same backend, backend part for the same task, but with a different set of technologies. For example, I decided to choose Golang as a programming language, AWS as a platform for the backend part, and this backend API is written with AWS Lambda, AWS Gateway. It uses DynamoDB and CloudFormation for the deployment procedures. With this set of technologies, I know that it's a very quick deployment. So I know that if we have infrastructure as a code, we can repeat deployment as many times as we need, and this is really easy in order to quickly ship the APIs. I also won't have any problems with SSL and certificates, just because AWS Gateway responsible for that. I know that I will have built-in logging and troubleshooting with AWS CloudWatch. I know that it's easy to develop absolutely everywhere. I don't need a special setup for my computer for the backend. I don't need to deploy databases, servers, and everything. Everything will be ready with a minimal configuration of any computer. And which is most important, it's easy to quickly destroy all backend when it's not needed. Source code of this demo backend is absolutely available on a GitHub. So why I decided to create this project? First of all, it might be useful for front-end developers who quickly need an API in case when they apply for the full stack position. This is exactly the case of my friend, where he is more a front-end developer than a backend, and he was applying to exactly full stack position. So he needs like something to take and something to like easy adapt for any type of test assignment in case if it's like a CRUD type of test assignment. Then I also think that this demo application might be useful for a backend developers familiar with the Go and with the AWS, just as a quick reference how to quickly develop and deploy with the CloudFormation. And finally, probably this demo might be useful to anyone who would like to know what is AWS, what is AWS CDK, and how everything amazingly works with the Go, and anyone who is just curious in the backend development. So, what we have? We have a web API with methods to register new user, to log in with a username. It also has couple other web methods like get information about myself, change role, get list of all users, and of course removing user from a system. This web API also has a product API like simple create, read, update and delete, something what is called product. We will see what product is later. And finally, this demo uses AWS notification service, DynamoDB, Lambda and Gateway in order to manage users and products. Basically, that's my story, and let's go to the demo. First of all, what I have is AWS CLI installed on my computer. I also have AWS CDK installed on my computer. And what I did, I created or bootstrapped CloudFormation for my account in the preferred region. With that, I also initiated an application using Golang with CDK. If we observe what exactly we built during the demo, it's a web API hosted on AWS with AWS gateway. So we have users gateway. We also have users function, which then talks to a message queue and the database. What we also have is a products gateway, products function, and the same database. So this is a simple structure of our test project with all moving pieces in it. We don't need to care about SSL. We have built-in CloudWatch. We have amazing scaling from the AWS. And also, the database we use, DynamoDB, is, I think, the most production-ready database for any type of load. In the source code, what we have is a source code for the infrastructure, and we have a source code for two functions, users function and products function. In the infrastructure part, we deploy from the code. We deploy database, queue, gateway, and functions. In the functions part, we have user function responsible for register, login, change role, and all the things. The same for the products. Let's take a look at the source code. So, what we have here is our demo API built with CDK, and here is a source code for the infrastructure deployment. What we have here is a deployment of a new queue, deployment of a new users table, another one table for products. We have function for the users and function for the products. We have all grant rights to the tables and functions. We have an API gateway for the user and API gateway for the products. Basically, that's it. This is the all infrastructure deployed in the AWS. Let's check what we have. Let's check what we have in our AWS console. This is my console. This is CloudFormation. Let's start from the beginning. It's a CloudFormation, and for now it has only the project itself initiated. That's it. Let's take a look what we have in the functions. For example, this is a function to handle a users. This is our routing, where we can register user, login user, change roles, get list, and everything. Let's, for example, take a look at the register user function. This is just a simple Golang code in order to unmarshal the type or the structure what we send. Then we check if user exists in the database. If it does not, we create new user in the DynamoDB. Insert user is a function where we take username, hash password, and some role, and then we just insert new record in the database. The same for a product. This is basically another Lambda function with the same structure. It has an app, API, database, and middleware layers, and it operates with something called product, which just a simple entity with an ID, name, description, price, and the manager who is responsible for the product. And manager, this is exactly the user from the previous entity. Our user is, this is database object with a username, hashed password, and the role. Okay, what we can do is we can build our function and then deploy with the CDK. Let's first of all try to build the user's function. Here we have make file with a command to build our project for the Linux AMD64, and then we just zip the binary of our function in order to later deploy to AWS. Let's try to build it. So I'm on Windows in the WSL. This is Ubuntu. Ubuntu command shell. What I can do is I can build my function. Here we have a binary and an archive in order to deploy later. What I also can do is deploy, is to build my products function with the similar script. As a result, we have a zip with our binary of the Golang built for Linux. What happens then is in our CloudFormation script, what we do is we take our function and deploy this as a Lambda function. The same goes for a product. In order to deploy, I can see a diff between something in what is in my source code right now and something what is on AWS. Let me remind you that it's absolutely empty right now, so diff will be huge. I have a lot of resources which are going to be deployed when I start deployment, and it has absolutely everything what I need for my demo. All the roles, all the policies, all the assignments and all the functions, databases, queues, and absolutely everything. This is a gateway with every public API, so it's a huge. What I can do is I can deploy my infrastructure right here. Of course, the first deployment will take some time, so we just need to wait while everything is deploying. We agree with this diff of deployment. Okay, we can see deployment is in progress right now. We have 78 something to be deployed, so let's wait. Okay, beautiful. It seems deployment completed, and as output we have two public URIs for our gateway. Let me make notes right here. We have two URIs. First URI is our gateway for our products, and second URI is a public gateway for users. We will need these links later. Let's check what we have in AWS. If I refresh everything, I have my stack deployed. This is all the information about the deployment together with events. Everything seems good. In the list of resources, I see all the artifacts I decided to use in my composition, which is a queue for sending messages. I have two tables, one table for a user and other table for a product. We will take this later. We have a user function and products function together with a user gateway and products gateway. All of this being deployed with a single script. What I can do next is check my gateways. Let's go to the user gateway, click on the gateway resource, and what we have here is, for example, login web API, which is a web method point to a Lambda function written in Go and deployed as binary. This is a register API call. This some other APIs from my function. Let's open another one gateway for the products, and products gateway has CRUD operation to create, list, get one, update and delete of something called product in the demo. Okay, let's try to use the deployed API, and first of all let's try to create new user. For that I need to get my user's gateway URI, which is this one. And what I'm going to do is I'm going to execute curl requests from my console. Okay, let's try to create new user. Here we have success response. It means that the user with a user1 and password successfully has been created in our system. Let's check first of all database. Let's go to CloudFormation and find our users table. This is our users table, and what we see here is a single record with a user1, hashed password and assigned role. What we also do is we send a simple notification message into the queue with information that user was created. This is our queue, and if we go to the messages of that queue, we can see that we have one message available. Let's try to see that message, exactly this one, and the message payload, new user created user1. So we can send messages then for async processing of the newly created users. Good. Let's try to log in with our user. I still need to get correct URI for my curl request. I will execute login request and get access token from my system. I need this token later, for example, to execute API requests. Let me put this token somewhere here. Okay, so we successfully authenticated with a token. Let's try to see what's inside the token. We have a user name and user role from the token payload. Good. Let's try to create a couple more users. I fix URI and execute curl request to create user 2 and user 3. In the database, let's go back to CloudFormation users table. We see 2 users created. Good. Now let's try another one API call, for example, to get list of users with correct URI and with a token. Yep, that's the token. Oh no, it seems it doesn't work. Let's try to find out what's the problem using CloudWatch. For that, we need to go to our function, users function, this one. In the monitoring tab, we can see CloudWatch logs. Open latest log. And this is exactly the problem. I have couple log messages when we verify user rights, and it seems that API method to get list of users is not available for a user. It's available only for someone with admin role assigned. Pretty easy to find any type of problems, because here we can see everything from our web API. Let's try to fix this problem by changing the role of the user 1 from the user to admin. We can do it directly in the database. Right here, role, I'm going to change to admin. Of course, for that we need to authenticate once again, just to get latest role. So user 1 will be authenticated once again. Let's verify what's in a token. New role is admin. Good. What we also can do is to get list of users once again, but with correct token. like that. Good. We have list of all users, user 1, user 2 and user 3, executed with admin privileged user token. Good. What we also have in our system is a list or like a function to handle products. Let me create couple products and get list of the product. So first of all, I need correct URI for my products gateway right here, like this. Like this and like this. And I of course need to have a correct token. Let me get the token. Good. In order to create product, I also need to be an admin, so let's go here, create product, create another product. Let's take a look at our products table, if we have anything there. Where is our products table? Here it is. It has two products, product 2 and product 1. Okay, let's get list of products. This API call is public. We don't need any tokens for that. And here we can see product 2 and product 1. Good. If we need to modify something during the, I don't know, during the development, let's take, for example, some kind of little modification like error. We have updated function. The deployment of the function after all resources been created is extremely quick. So I'm going to go to my Lambda user function, build new version of my function, done, and then I need to deploy updated version of a function with CDK deploy. It will deploy only a difference between something what I have here and something was deployed. In this case, it's only binary of the function, and deployment itself is very simple, very quick. Let's check. Have new function deployment with the same URI. No need to change URI because we changed only function. Gateway has not been updated. Basically that's it. So we have pretty quick and easy CLI based type of deployment of production ready web API. Deployment done. Deployment took 48 seconds to have new version of the project deployed to the AWS. When we're done with all our development, what we definitely need to do is to destroy all the infrastructure. Let me go to my stack. This is my stack, all the resources. When I'm done, what I need to do is just to destroy everything with a simple command. Let's wait for it to be ready. It will ask if I'm sure and if I would like to proceed. In this case, yes, I'd like to remove all infrastructure. And for example, when my job interview and demo process is done, I can easily delete all consumed resources from the AWS. Let's wait for it to be ready. Okay, deployment done. We have a message that everything has been destroyed. If we take a look at our CloudFormation stack and refresh, we don't see our composition deployed. Basically, that's it for the demo. Let's hope it will be useful for anyone who needs a quick backend deployed and to be ready for a demo or for a simple production. And good luck with your job interviews.